Good afternoon, everybody. I think that we're about ready to go. We have people still signing in, and I think they probably will for the next little while, but we'll go ahead. So welcome to the Grain Drying and Storage webinar. My name is Morgan Kotz. I'm the field agronomist for the Manitoba Corn Growers Association. This webinar is brought to you by the Manitoba Canola Growers Association, Manitoba Corn Growers Association, Manitoba Wheat and Barley Growers Association, the National Sunflower Association of Canada, and the Canola Council of Canada. As you can see, their logos in the bottom corner. That's who you can thank for bringing this webinar to you. As commodity organizations, we decided this was a great fall to go ahead with some kind of grain drying and storage session. A webinar, of course, works great because no one needs to travel, and we all have the webinar recorded and archived so that it can be viewed by anyone in the future. All of the organizations I spoke about will have the recording available on their website by next week, I think. So also in the side taskbar that you have, there's a handouts tab where you'll find both presentations that are available to download if you're interested in printing them off and following as we go along. So today we're very fortunate to have two experts on drying and storage. I'll introduce Dr. Hellevang first, and then he can proceed with his presentation. Then I'll introduce Charley Sprenger from PAMI, and she'll present. We'll save questions until the end. I have a few questions from Twitter. If we have time, you can enter your questions in that questions tab on the taskbar. Dr. Kenneth Hellevang, pictured here. Ken has a PhD degree in engineering, is a registered professional engineer, and has obtained the academic rank of tenured professor at North Dakota State University. As an extension outreach engineer of agriculture and biosystems engineering at North Dakota State University, he's provided education and technical assistance in grain drying and storage structures with focus on energy efficiency, indoor environmental engineering, primarily related to moisture and mold, and flood preparation and recovery to farmers, citizens, agribusiness, and professionals across the US and internationally since 1980. He has a long bio here. He has conducted research on numerous grain drying and storage topics, including moisture content changes in stored grain during summer, drying and storage of edible beans, air temperature increase due to grain drying and aeration fans, aeration duct design, and soybean storage. In addition, he developed a system for and has conducted numerous grain dryer energy audits. He's been an expert witness and consultant for several clientele. He currently serves as interim chair of the NDSU Department of Agricultural and Biosystems Engineering. He and his wife Myrna live in Fargo, have 3 adult children and 7 grandchildren. So I will pass the stage on to Dr. Hellevang, and you can proceed whenever you're ready.
Okay, good afternoon, everyone. This fall is certainly offering us many challenges across all the different commodities that we are working with. And I've tried to select or identify some key topics that I'm receiving questions on, and we'll have time at the end of the 2 presentations to do additional Q&A. So As we're going through, if you've got additional questions, things that you want me to elaborate on, feel free to jot them down, and hopefully we'll have time to go through those. One of the questions that I've been getting frequently is farmers who are thinking of leaving their corn stand in the field over winter to obtain drying out in the field. And certainly that will occur. This chart or table shows that as we get to the cold temperatures of winter, though, that the amount of moisture removal ends up being very small. And so, yes, we will probably go from in the upper 20% moisture range to about 20% moisture over winter. But that, of course, will come with some risks. So leaving it out there for an extra week or two really doesn't change the moisture content a whole lot. So if we have people that are considering, do I leave the corn stand or harvest, keep that in mind. Also been getting a lot of questions related to what I call the corn flowability issue, that if we are looking at extremely wet corn out in the field, can I harvest that, put it in the bin, and will it come out again? Based on previous experience, what we have found is that if we're in the upper 20s, that 27 to 28% moisture range, the kernels do have enough surface moisture on them that they will bind together or freeze together. Those that are harvested at temperatures below freezing stay below freezing and are unloaded as we're going through the winter months will probably do okay, but there is that danger of them not flowing out, even down to about 24 to 25% moisture. I really feel that in order to assure that we're not going to have any flowability problems, that we need to be at less than 24% moisture. And of course, foreign material in there impacts it as well. As we're making the decision as to whether we should leave it out in the field or not, we've talked about that we're probably going to be in the 19 to 21% moisture range, but there's also the danger of field losses. And anyone that is considering leaving the corn stand, I'm strongly encouraging that they check the stock strength. Starting to get reports of corn that did have weak stalks. If you go out there and push on the stalks, they're tipping over and they might look like that field in the bottom left picture. Also, we should check and see how well the corn ear is attached to the stalk. That if that is not bound well, then we'll end up losing the cobs on the ground, and that ends up to be a very significant loss. There will be snow accumulation, of course, over winter, and that's shown in the bottom right picture. And here in North Dakota, we typically have 4 feet or more of snow accumulate over winter. If that's standing out in the cornfield, that amounts to about 4 inches of water. And as that melts in the spring, that's going to create some very wet soils. In addition to that, the corn tends to create a shade or sheltering effect, slowing down the dry down of that soil in the field. So my recommendation really is to harvest, if we're going to leave it stand, to harvest end of February or during March before we have any chance of the ground melting and running into trouble that way. Also wanted to spend just a little bit of time talking about the ability of our moisture meters to accurately measure the moisture content. Most all of our meters are calibrated around 15% moisture. And when we start trying to measure corn moisture contents at 25, 26% moisture, there's going to be an error. We can't necessarily quantify just how much error that will be because it's going to vary from meter to meter. But we do know that it could be off a point or two. Also, most of our meters need to make adjustments based on temperature. That if we're particularly at cold temperatures, some of our meters are not even accurate at that temperature. And all of my numbers here are going to be in degrees Fahrenheit. But as we're approaching temperatures near freezing, verify whether your meter is making adjustments and is accurate at that temperature, because that too can cause a significant error. Most of our moisture meters are more sensitive to the outside of the kernel than the true moisture throughout the kernel, which can cause us problems. If we have a condition where corn is coming out of a dryer, where the outside is drier than the inside, that's going to fool the meter. Or if we have a scenario where there's condensation on the surface of the kernel, that too will cause the meter to be in error. In both cases, we really can't predict exactly what that error will be. So I really recommend that we check the moisture content with our meter, place the sample in a sealed container, let it sit for 6 to 12 hours so that we come to equilibrium, and then recheck the moisture content to verify if the meter is being fooled and likely how much that meter is being fooled. This is a table that shows the recommended long-term storage moisture contents of some of our different crops, and the numbers may be slightly different depending on climatic conditions. This is assuming summertime temperatures of 70 degrees, and it says 60% relative humidity here on the slide because I like to keep the relative humidity within the spaces within the kernels under about 60 to 65%. At 70%, we'll typically see some mold growth starting to occur. So if we're sitting with something that is going to go into summer storage or long-term storage, these are the target moisture contents that we would need to be looking for or targeting toward. However, if we're starting to try to figure out what we can get by with, I refer people to this table that I have, which is the approximate allowable storage time for cereal grains based on some deterioration taking place, but not a total spoilage of the grain. And so if we're working with corn, and we'll just pick on 24% moisture corn, and if we're at 130 degrees, we've got about 130 days of allowable storage time. So as long as we keep that wet corn cold at temperatures below freezing, we can store that corn for an extended period of time through the winter without any quality loss or major change in quality. However, if we get into a condition where we're seeing temperatures of the grain around 40 degrees, then we only have about 40 days. This becomes important for us because I have a number of farmers now that are harvesting high moisture corn putting it into storage, basically wet storage, with the expectation that they're going to be able to take that corn out and run it through their drying system fairly soon. And that might be within a month, it might be within 2 months. As long as they keep the temperature of that grain cold, below freezing, we can do that. But it is going to require airflow through the grain in order to hold that wet grain for drying at a later point. So let's talk a little bit about our options for drying this high moisture corn. Most of it is probably going to need, if it's very high moisture, going to need to run through some type of a high temperature dryer. There's a tendency when we have high moisture grain to, I call it, push the system a little bit. We're running with higher temperatures than what we would probably think would be optimum. Therefore, we're drying a little bit faster. Also, we're probably in the dryer for a longer period of time just because of the high moisture grain. The fast drying, the fast cooling typically will end up with broken kernels and a lower final test weight. Number of guys this year are even looking at it as a two-stage process where they're harvesting their corn at maybe 27, 28% moisture, running it through the high temperature dryer, bringing it down to 20, 21% moisture, and then are storing it until they can finish drying, or brings it down to the point where they could do natural air low temperature drying. I'm not hearing a lot of reports of any caramelizing taking place, but certainly anytime we have high temperatures, where we have the potential of scorching the kernel or causing damage to the kernel, and reducing the plenum temperature is one of the things that we can do to try to maintain the quality of that grain. Some are trying to make a decision between leaving the corn in the field and the losses that will occur there versus the cost of doing the drying. Just as kind of a rule of thumb, I typically will use the top equation, assuming an average of about 2,500 BTUs required to take out a pound of water. And so if we're working with propane, we can estimate what the propane or energy cost would be by taking 0.022 times whatever the propane price is. So if we're looking at $1.50 per gallon propane, that ends up being about 3 cents per bushel per point of moisture removed. If we're taking off 10 points, we're then looking at about 30 cents a bushel as a drying cost. As we start making a comparison between what our drying cost might be versus leaving that corn in the field and the field losses, this is an easy way to at least get a ballpark estimate. One of the things that I think people need to keep in mind is that the colder the air is outside, the more energy it's going to take to heat that air. And this is a table that I put together that really looks at how drastically that can change. That if we're looking at, let's say, quote, an average year where we might be drying when it's 40 degrees outside, with $1.20 propane, that ended up to be about 14 cents per bushel, taking off not quite 5 points of moisture. If we do it when outside temperatures are 0, again, degrees Fahrenheit, that jumps up to about 19 cents a bushel. So the colder it is, certainly the more it's going to cost us to do the drying. and that too needs to be factored in as we're making our decisions of, do I dry now, do I wait, what's going to be the ramifications of that. One of the questions that is causing a lot of irritation this year is that test weight is not behaving the way it does most years. Most years, as we dry the corn, we would expect the test weight to be increasing. Some of the primary things that affect the test weight change as we're drying is the amount of kernel damage, the drier temperature that we're working with, to some extent even the corn variety. This year, where we're talking about high moisture corn, I think we're seeing where we have more mechanical damage. The higher the moisture content, the more fragile that kernel becomes. The colder it is, the more fragile that kernel becomes. And so we're seeing a much higher mechanical damage over here on the left side of our chart. Then when we look at what we would expect the test weight increase to be as we're drying, what we see is that mechanical damage makes quite an impact on the increase in test weight. So in most years, I say that we would normally expect to have about 1/4 to 1/3 of a pound increase in test weight as we take off a point of moisture. This year, that's unfortunately on the corn calls that I'm getting not happening. I think there's a couple of things that are contributing to that. In addition to the harvest damage, some of the literature shows that the cool fall, even though the corn may have reached physiological maturity, didn't fill that kernel out the way that it would if we had warmer temperatures. So unfortunately, I'm getting a lot of calls on corn that might be 49 or 50 pound test weight, and it just isn't increasing much going through the dryer. One of the typical recommendations is to reduce the drying temperature so that we're more gentle on the drying, and that helps maintain the test weight. If you look at dryer designs, many of the dryers today have some type of diverters or other means of mixing the corn as it comes down through the drying column. And what we would typically expect then is that is more gentle on the corn. It's not exposed to the heat as long, and therefore we would expect a higher test weight. And again, we're seeing maybe a little of that benefit this year, but not as much as what we would hope or anticipate. Now I'm just going to run through a series of slides very quickly to give you some of my general guidelines on some of the other types of drying systems. Anybody that's doing air drying or natural air low temp drying, the maximum moisture content that I recommend is 1 CFM, or moisture content is 21% moisture, airflow rate 1 CFM per bushel. Unfortunately, that does not work well at temperatures as we get near or below freezing. And so we're basically holding it over winter and doing the drying in the spring. This is a chart that I put together to just emphasize that we can add supplemental heat. Typically, we would think that would be a benefit and it helps us a little bit. But unfortunately, when it's so cold outside, we're primarily over drying the grain, obtaining a lower moisture content than desired, and we're still looking at very long drying times. And that, of course, is related to the moisture holding capacity of the air. And here we can see that as the temperature decreases, the amount of pounds of water that can be held goes down significantly. And we get to the point where it just isn't holding enough moisture to make it worth the effort. Spring drying, in contrast, works very well. Again, I recommend starting the fans when outside temperatures are averaging above about 40 degrees, and that then will allow us to do spring drying. With canola, listed here some different moisture contents and the typical types of drying temperatures that are recommended. Generally, we need to limit the temperatures as the moisture content increases. And that's going to be true pretty much with all our types of grain. Natural air drying generally would work fairly well if we were doing it in September and October. But again, as we get late fall, early winter, moisture holding capacity is going to be gone. The other thing, of course, that most all of you are familiar with is that at these airflow rates which are required, we have to limit the grain depth in order to get enough airflow through in order to do natural air drying. Couple slides on wheat. Normally what I recommend is 17% is the maximum moisture content. Need an airflow rate of about 3/4 of a CFM per bushel, and it'll take about 31 days. But that's assuming a temperature of about 70 degrees. And once we get into a late fall, we really need to just shut the system down, hold it over winter, and do the drying in the spring. And this just shows again that in the spring, as we look at typical April conditions is roughly equivalent to October. May conditions fairly similar to September. And so generally my recommendation is with wheat that we hold it and wait to dry until we're getting closer to 50-degree temperatures rather than the 40 that I talked about earlier for corn. Soybeans would be similar for sometimes sunflower. We typically in soybeans need to limit the temperature in order to not damage the seeds. Sunflower, we typically can handle higher heats, but in both cases, we have a drier fire hazard when we're drying that grain. The pods, trash, other things accumulate in the dryer become combustible. So it's critical that we keep the grain flowing in the dryer, keep that dryer clean, and then constantly monitor it. So quick run through, primarily focusing on corn, touching a little bit on some of the other types. High temperature drying would still be working this time of year, but as far as air drying, we're probably in a hold pattern until spring when hopefully conditions will be better.
Thanks, Dr. Hellevang. I'll just change my screen over here quickly. So if anybody has noticed the handouts in the taskbar, Dr. Hellevang has his presentation there in a PDF file. He has a little bit extra information on storage as well, so it's a good handout to download, I would say, if you haven't done that already. So thank you again, Dr. Hellevang, for providing that information for us. Next, we've got Charley Sprenger from PAMI, the Prairie Agricultural Machinery Institute in Porterville Prairie, Manitoba. Presenting, Charley received her degrees in biological engineering from the University of Saskatchewan with a focus on biomass handling and processing. Since joining PAMI in 2017, she's been instrumental in their grain storage research program aimed at providing producers with the tools and knowledge to make informed decisions on their farms. Charley also leads a variety of projects on the agronomics and logistics of on-farm practices. Her family raises a beef cattle herd near Rivers, Manitoba. So Charley, I will pass it over to you now. Have a moment. And you can take over when you're ready.
Thanks, Morgan, and thanks everybody for joining us today. Definitely happy to be, it's a fall that this is definitely a hot topic and lots of information. I'd really like to segue onto the grain storage principles and take more of a basic principles approach. It's how we like to do some of our extension presentations, really providing a set of tools and process flow of decision making for producers to use when storing their grain. A lot of this presentation will focus more on wheat and canola, as those are some of our main commodities on the prairies, but Dr. Hellevang talked about corn a lot, so that fills in some of the gaps. So just to go through a couple of different topics, basics, looking different some tools, new technologies, and touch on supplemental heat, maybe a few additional things to Dr. Hellevang mentioned. But if anything, the take-home message from this presentation that all types of grain storage and aeration require proper monitoring and management. So the better understanding you have of your system, the better management decisions you can make. So we know there's lots of different options for storing your grain, from bins, bags, etc. I'm going to focus mostly on in-bin, but the same principles apply across, just different management practices. So our issue really is avoiding spoiled grain. The important thing is that potential for spoilage depends on both temperature and moisture, and the chance of spoiling when it's hot or moist affects insect, fungal, etc. So the key again is both temperature and moisture. As most are aware, we need to cool and dry that grain for safe storage. So you can limit these variations in temperature and moisture by blowing air through the grain, and this helps even out temperature variations. But blowing hot air does dry grain more effectively, because the warmer the air, the greater its ability to hold moisture. But heating air for grain does cost money, so trying to find the best management principles. So moisture variations are also, as well as temperature, are key, and that we want to mitigate any moisture migration or hot spots that could be prone to spoilage. So these are just examples of some convection currents which affect, as well as airflow through the bin when you have aeration. So the Canadian Grain Commission has safe target storage condition charts that can be used as guidelines for various commodities. I'm not sure that corn is one of the charts available on their site, but most of the other commodities are there. Keep in mind that these are guidelines, and that pockets of high moisture, high temperature grain can create problem areas. So really being able to monitor your bin conditions is important. But we can condition our dry grain if it comes off the field too hot or wet, using heated air or natural air drying. So aeration versus natural air drying, Dr. Hellevang talked on both a bit, but the difference comes down to what we're trying to achieve. So aeration, we're just cooling the grain, conditioning, low airflow rates around that 0.1 CFM per bushel. If the air is cooler, the grain will cool. Straightforward. Take up to about a week to equalize depending on your ambient conditions. This is mostly used earlier in the harvest season when we're trying to cool the grain as it comes off the field. But this time of year as well, as we're putting in the bin, it just won't take as long. Natural air drying, if we're harvesting tough, we can get some reduced moisture in the grain as we put it in the bin with higher airflow rates if the air has capacity to dry, which I'll go back into a little bit more. But we want, airflow rates up around 1 to 2 CFM per bushel depending on the commodity. But once again, ambient conditions really affect. So if we have cool, humid weather, we're not going to achieve the same drying. But as a general recommendation, we want to, if you can, run your fans continuously to keep the grain bulk conditioned, cool temperatures, and evenness throughout the bin. Regardless of what we're talking about, aeration and natural air drying, it's all about the airflow rate. Each specific fan, its airflow rate will depend on static pressure in the bin, and static pressure depends on grain type. So the smaller the seeds, the smaller the voids, so greater resistance to push it through the grain bulk. Depth of grain effect, so the greater your grain depth, how full your bin is, the greater resistance. Airflow rate, the faster you try and push air through the grain, the greater the resistance to airflow. And distribution system, so your ducting system, depending on the setup, will also add to static pressure. This is an example of a fan chart table. You might also see fan curves. So this is what you'll definitely see from your fan manufacturer, and you can, depending on if you know what static pressure you're going to get from your depth of, or your grain bulk, you can use this to select the fan, or if you have a fan fit on your bin, you can work backwards and see how deep you can fill your bin in order to get the airflow rate that you want to achieve. And then if you want to look at your, find your static pressure charts, there's charts available generally to estimate. We've got some available on PAMI.ca. Fortunately, I didn't get these in this presentation. But you can also get, measure your static pressure on your fan outlet to measure your actual in the bin to see if you're maxing out your static pressure. Other bin considerations, bin fill. There's some research has said that if you can even out the bin, you'll get more uniform drying or airflow through the bin. The air will go through path of least resistance if it's all level. Exhaust vents, this plays in particularly when we're adding heat and trying to grain. If you have exhaust vents, then prevent condensation on the roof falling down the walls to the grain. So if you can vent it out of the top, that's useful. Other aeration drying challenges, small seeds, so high static pressure, I mentioned that, so possibly might have to fill your bin only a quarter or halfway, depending on how tough that grain is, to reduce the static pressure and get more efficient drying, and then move it to another bin. Some crops will respire for up to 6 weeks after harvest, so moisture can be generated during that time, so that's another reason to have your fans run constantly for for the first while anyways, until maintain equilibrium. And as well as green seed can result in high moisture pockets and then heating and spoilage. So there's been a lot of talk about the past several years of when the best time to run natural air drying fans. IHARF Indian had published recommendation just to run fans at night, but there's no one perfect answer that was trying to generalize it. So the best strategy really is depends on your condition, your grain type, moisture. So using those tools and figuring out what makes sense for your situation. So I mentioned that we can achieve some drying when air has the capacity to dry. So the ability of air to hold moisture depends on its temperature, and equilibrium moisture content, which we refer to often as EMC, is a function of air temperature, air humidity, and grain type. So each commodity is a little different. So I have an example in a minute, but here are the charts that you can see. We have these available on our website as well for reference. So example, this is wheat, and at a relative humidity of 70% and a temperature of 10 degrees, if this is your ambient conditions, that's maintained over time, your grain bulk will eventually equilibrate to 15.7%. Similar to canola. So if you're but really this theory too is complex because mass transfer, water between air and grain is complex, but it can be used as a tool and a guideline for estimating when the air has capacity to dry and manage your fans. Even though it fluctuates through the grain, we'll have an average daily temperature and humidity we can use. So just as a representative that people find useful to see when grain has capacity to dry. So we've got warm air, humidity hits the cooled grain, and and then we've got cooler at night, air at midnight hits the warm grain, so we've got a bigger cup. So you can use a cup analogy for how much capacity it has to dry. So we overflow the smaller the cup. When we have warm air, the cup gets smaller, but we have the same amount of moisture in it, so it overflows and gets some rewetting. Whereas if we have that cooler air, our humidity, the grain causes the air to warm up, the cup becomes bigger and it has more room to take up moisture. So in general, yeah, if we have warm air and warm grain, we get some drying. Warm air, cool grain, wetting. Cool air and warm grain, we get some short-term drying until it steadies, and then cool air and cool grain, you get some minor wetting. So in answer to when's the best time to run your fans, really depends on your goal. If you're trying to get safe storage for all grain types, just run fans continuously to keep things even in the bin. If you're trying to minimize your fan hours, run fans when greatest capacity to dry, so you can turn them on and off. That's not always most effective or most realistic to turn them on and off. Just wanting to cool the grain, run them at night only. If you have a high capacity fan, or continuously with low capacity. Even moisture content profile with no over drying, run during the day, and then just aerate to even it out. In any of these cases, monitoring your bin and knowing what's happening in it is really important, so that you know if you have problem areas, you can mitigate fast, or you can decide how long you need to run your fans for. So here's just some examples of technologies out there, from your moisture sensing cables to new 3D mapping, for example, GrainViz. Dr. Hellevang definitely touched on supplemental heating. It's not the same as heated air drying. We're just adding heat to your natural air drying in-bin systems. But it allows us to extend season of good drying up to 20 degrees. So that's good, considered good drying, is in that 20 degrees. So when we're in that 0 to 10 or even slightly lower, we can try and bump that season up longer, so we don't have to put everything through the dryer. Still using natural air drying airflow rates, but that's important. We have to make sure we have sufficient airflow. So good drying weather, like I said, requires temperatures above 10 degrees Celsius and lower humidity below 70. Anything below that, any possible drying, even if the equilibrium moisture content and humidity is lower, the drying rate will be very slow. So rule of thumb that we recommend is limit your temperature increase to 10 degrees or less to reduce fuel costs and unevenness through the bin. Don't exceed inlet temperatures of 20 degrees or 20 Celsius. Once your inlet temperature drops below 5, you're not getting very much drying, like I mentioned. Rule of thumb is that for every increase in temperature of 10 degrees, the RH of the air is effectively cut in half, so you drastically increase the capacity of the air to dry. Make sure you can get sufficient airflow above around 1 CFM per bushel, and that you have adequate ventilation to get that moisture right out of the bin and avoid condensation. So this is the example of where the humidity is cut in half for 10 degrees increases. Air, so your equilibrium moisture content of where your grain can be dried to is much further down. So just a few examples. I'm not going to touch on this too much, but they'll be in the handout for you to look at, and there's more resources on our site for sizing your heater and deciding what you need to achieve some drying. These are old cost of fuel, but just example in that 50 cents to $3 per hour in fuel, depending on type of system. So these are some examples. You can add heating systems upstream, downstream. There's definitely different options. So some are easier to implement, the upstream suitable for just transferring between bins and retrofitting, or downstream slightly more energy efficient, but requires more difficult installation. A couple of years ago, we did some research looking at summer storage. So we're looking now at once we've stored the grain in the bin and we've got it through the winter, even if it was a little tough, a lot of questions about what do we do in the spring if we have to store it. So I'm not going to touch too much on that, except our conclusions. So really, we looked at aerating the bin, turning the bin, or just leaving it alone. So found that leaving it alone was actually the best option. This is for canola. Plenty of heat migration, but no moisture migration. So that it maintained fairly stable as it's coming out. I talked a lot about natural air drying, but as far as aeration, just best management practices, we want to run those fans continuously until we've cooled our grain sufficiently, low airflow rate, and just to even out the temperature distribution. But if in the case that we're not able to dry tough grain before winter, either it's not feasible to add supplemental heat, or you don't have a heated air dryer, you can freeze grain by aerating in cold temps, but really you should try and haul your grain before the temperatures warm up too much. You don't want to store it over summer. Well, these I already mentioned, talking about other drying challenges. Apologies, those are duplicated, but important to keep in mind. So there's a lot of overlap from what Dr. Hellevang mentioned for drying in bin, but really it's maintaining safe storage conditions and trying to manage that in your bin as you take it off harvest and going into the winter. So requires management of both temperature and moisture. Main difference between aeration and natural air drying is airflow rate. Many factors affect that air's capacity to dry, so you got to look at the conditions that you have, the type of grain you're storing. Supplemental heat is a good option, but if you have to, get it cool and keep it cool through the winter. So just monitor and manage. As I mentioned, we've got quite a few other resources. These are just an overview for today, but at PAMI.ca/storage. And I wanted to thank Manitoba Agriculture for supporting some of this extension work. I'm going to be speaking at Crop Connect in February, hoping to revamp this presentation and change it a bit to answer some more questions from some of this fall and some of the challenges we had. So definitely looking for some feedback on information that you're producers are looking for. I think that's it for me.
Perfect. Thanks. Thanks, Charlie. I'll just switch over here again. So I'm getting a few questions or comments that for some reason I couldn't get the handout of your presentation, Charlie, to load in the handouts. It's not working properly. So if anybody wants it, email to them. They can send me an email at morgan@manitobacorn.ca if they want it, and it'll be good for if you want to review this webinar once it's archived. I'm sure you could send an email to Charlie too if you wanted the PDF version of the presentation as well. So my apologies for that. Dr. Hellevang's is working just fine, it seems, but for some reason the other PDF isn't. So we had some questions from Twitter using the hashtag grainstorage19. I'm gonna post them up here so we can view them and fire them away. Sorry, here we go. Can you guys see my screen now?
Yep.
Hopefully that's a yes. Okay, perfect, thank you. Okay, first question. I'm not sure which one of you might want to answer this. What is the margin of error with grain moisture meters, particularly with low temperature and or very damp grain? Do you have an answer for that?
Well, I'll take a first crack at it, and I don't know that we can really indicate what the error would be. It's going to depend on the meter. It's going to depend on the operating conditions, but would be just safe in saying that, as I indicated in my comments earlier, that temperature is a contributing factor that is looked at when we measure the grain moisture content, and that could cause an error easily of at least a couple, 3 percentage points. And the same thing with very wet grain, that since calibration is typically around 13 to 15% moisture for most of our cereals, that if we're up in the 25% range, it would be very easy to be off a couple percentage points or more. So can't give a specific number, but just that there certainly would be an error. And I'll do a first attempt at this one, and then we'll go from there. There's a lot of different designs in dryers, and there's pros and cons with various aspects of what is incorporated into a dryer. If there was one best method, all the dryers would be the same. But there are a variety of features, a variety of ways of accomplishing the end goal of drying the grain. In general, we could walk through some of the operating characteristics of each one, but I think the end result is that there is not one best type, and each design is going to be operated a little bit differently to obtain the best efficiency and drying parameters. So we will see a variation from dryer to dryer.
Okay, thank you. I like this one. How does freeze drying work, or does it? Is it ever practical to dry cold grain with cold air? At what moisture content? Is it a concern for the bulk to set up or freeze solid in a bin?
Charlie, do you want to do that one?
Sure, I'll try. So I really can't say what the moisture content would be to result in freeze solid, at least for wheat and canola. But if it comes down to it, that it's definitely an option to try and just get your grain cool. You're not going to achieve much drying by blowing cold air in it, but you'll at least have grain that's safe to store, and your risk of spoilage is a lot lower. So we definitely haven't done much work in this area, but it is an interesting thing that might be worth looking at.
And I guess I would take a stab at the first part, freeze drying work. And I usually use the scenario that we can hang clothes out on a line in the wintertime, and moisture will go from the liquid phase to freezing, and then will move from a frozen state to the air, and eventually sublimate to the point that we have a moisture reduction. But we could see a little of that happen out in the field, but it's going to be a very, very slow process. As I indicated in my slide during my presentation, that yes, we will see drying occur or a moisture reduction occur if we leave corn stand out in the field over winter, but it's going to happen very, very slowly. And assuming that the wind blows, we might be looking at hundreds of CFM per bushel going by that corn. If we put that grain in a bin and now start trying to move air past it, again, if you look strictly at the equilibrium moisture contents that Charlie was talking about, yes, it may appear like we are drying, but the rate of drying is going to be so slow that you're going to spend way more electricity than any benefit that you would get. So there's nothing magic about it going through a freeze and thaw cycle. Yes, there will be a moisture change that will occur if there's enough wind blowing by, but to try to freeze dry any grain in the bin just isn't practical. As you can probably tell, I've had that question before.
Probably a lot this year. Okay, when drying using heated aerations, what's the maximum inlet temperature you can safely use for canola?
I'll let Charley
on
that one.
Charlie?
Sorry, I had a colleague pass answers to these questions that we got in advance, so I'm just grabbing his answer. So really, the maximum inlet temperature would be grain drying temperatures around that 10 to 20, but maximum plenum is usually around 30 Celsius is recommended. If you're using supplemental heating for aeration, you usually want in around that 10 to 20 degrees Celsius, though, with sufficient airflow to reduce any possible degradation. So, but in heated air drying, I think 30 is recommended.
And the one thing that I'll add to that is that anytime we're moving air through grain to dry it in a bin, that we do have a drying zone where the drying takes place. The air comes in at a certain relative humidity or moisture content, moves through the grain, picking up moisture from the grain, and then will exit out of the bin. And typically I hear reports, well, the bottom of the bin ends up over dried and the top isn't dry. And of course, that's what's going to happen, particularly when we're adding supplemental heat, because when you go back to the tables that Charlie shared, or if you look at equilibrium moisture content charts, that when you heat the air, you're probably ending up down with moisture contents that might be 5–6% moisture. And so the bottom ends up coming into equilibrium with that condition. The top is going to be at a higher moisture content. And so either the whole bin will end up at that dry, what I call over dried condition, or we end up having to stop the drying partway through, mix the grain, and end up with a mixed moisture content closer to what's desired, unless you happen to have a market where they will automatically do that. They take and sample each load and average them out over what you're hauling in. But typically that moisture variation is an issue in many cases.
I don't know if either of you will have the answer for this. What effect does over drying for the purpose of blending with tougher product have on the oil content of canola? I've also got this question in to Angela Brackenreed. She's hopefully listening and texting me the answer right now, but I don't know if either of you can answer that.
I don't have a specific answer, but working with soybeans and sunflower, other oil crops, just drying to a lower moisture content really isn't typically going to cause a problem with the quality of that oil. If we're using excessive temperatures, that can have an impact on oil quality, but the moisture content is not an issue. The concern that I would have with that is making sure that we're blending the two together and getting a good mix of that moisture content so that it can equilibrate. Again, I don't have a lot of research on those oil crops, but I know that with the cereal grains, you can mix two different moisture contents together. And I'll usually use the example, if we have 20% moisture corn and 10% moisture corn, you average them together and that would be 15. but if you actually look at it on a kernel by kernel basis, that even if you mix them together, the 20 comes down a couple points or so, the 10 comes up a couple points or so, and you don't end up with kernels that are actually at the average moisture content. By moving some air through the grain, giving some time for that air to move the moisture content, we can help to equalize that moisture content a little bit more. But we do not truly end up with kernels that are always at that average moisture content. So blending, that would be more of my concern than oil quality.
Yeah, and I guess I'll just add, I think it's your drying rates and the temperatures you're using to dry that canola is more likely to have an effect on the oil content than the actual moisture content that you end up with if you're over dried. So.
Okay. With supplemental heat aeration, at what ambient temperature does condensation become an issue, and what steps can be taken to reduce it?
Charlie, you want to do that one?
Sure. So I can't necessarily say what, give a temperature. It'll definitely depend on the ambient humidity as well and how much moisture you're taking out of your bin. But as far as steps to reduce that, I mentioned ventilation, roof ventilation on your bins so that moisture is exhausted out or through the roof rather than running back down. The bin walls is a concern that producers have, so that's definitely an option.
Yeah, and I'd just add to that that as I'm visiting with people, I remind them that condensation forms on cool surfaces. And the colder it is outdoors, the more likely we will have cold bin roofs and walls. And that then increases the potential for that condensation. So I think that definitely is part of what needs to be considered in addition to how much supplemental heat that we're adding. I tend to recommend less addition of supplemental heat maybe than what was mentioned earlier. I typically try to keep the supplemental heat when we're doing natural air low temp type drying to something in the neighborhoods of maybe 3-4 degrees Celsius rather than going more than that, just because of the potential for over drying and the potential for condensation.
Okay. What are the limits of high temperature drying cereals and canola when it's snowing, raining, or high humidity?
I'll take a first one on that. With high temperature drying, usually I'll walk through the 20 degree, I use Fahrenheit, so it's 20 degrees rather than 10 degrees. Increase in temperature cuts the relative humidity in half. So we can start out with 100% relative humidity outdoors. And as we start adding that supplemental heat, pretty soon we're down to maybe 1%, or even in the cases of corn, lower relative humidities in the air. So certainly we're not as efficient drying cereals when it's very wet outside, but we can, in a high temperature dryer, continue to do drying even under damp outdoor conditions. Now, with
a little bit.
the kind of canola lower temperatures that were talked about earlier, they're going to be more impacted, but I think also they're pulling snow or rain in would be more of an issue than just the high humidity condition.
Okay, How are you guys doing for time? We have a couple questions from the crowd here.
I'm okay.
Yep.
Okay, Charlie?
Yep, we're good.
Okay, I'll read them out to you. Just a moment here. What would be the optimum relative humidity while storing wheat?
Well, if you look back at my table that I shared, I go with looking at the airspace between the kernels as being between 60 and 65% relative humidity. And at that point, we're typically going to have dry enough grain that we're not going to have mold growth and deterioration taking place. So when we're looking at wheat, for example, that ends up in that 13.5% moisture range. If you can be assured that it's going to be stored cooler than that 70 degrees Fahrenheit that I talked about, then we can go a little bit higher than that in moisture content. Over winter, we routinely have people storing anywhere from 16 to 18% moisture wheat as long as it's kept cold. But then as before we go into a warm environment, then I recommend it be dry to that 13.5%. And typically, like I say, that is in the 60 to 65% relative humidity range.
Yeah, and I agree with everything there too.
Okay. How do you get rid of ice on roof and exposed walls that builds up from condensation?
Very good question. If it's ice on the inside or ice on the outside, I guess I'm assuming it's cold enough that they're getting condensation and ice on the inside. And unfortunately, I don't know that there is any kind of easy solution to that. They need to be aware of that condensation and ice issue and probably need to remove the grain before it melts, because I get quite a few calls from people that end up with spoiled grain along the bin wall, and I'm convinced it's coming from either condensation running down off the roof onto the walls, or actually condensation on the wall, particularly with corn, where we're dumping warm grain coming out of a grain dryer into a bin and ending up with condensation along that wall.
Yeah, and if you're getting ice buildup on the inside, I'd say it's about too late. I'm not sure, what your options would be. And then, moving that grain before it warms back up will be necessary.
Okay. Angela Brackenreed had mentioned on the last question, she has a point to make for the supplemental heating. You only want to increase the ambient temperature about 15 to 25 degrees Celsius, inlet temperature 30 to 40 degrees, but you need to ensure at least 0.75 CFMs per bushel, ideally at least 1 CFM per bushel. So supplemental heat basically is not an option now just because it's too cold outside. We need to use the cold temperatures as our friend, and if we have tough or damp canola on the farm this winter, we can stabilize with freezing temperatures, want to try to get those temperatures as even throughout the profile as possible. Hopefully that makes sense to everybody. What is the maximum inlet temperature if you want to keep wheat or barley for seed?
The general recommendation that I see for maintaining any germination of any of the commodities is 110 degrees Fahrenheit.
Yeah, I don't have an answer on that one.
Okay. Okay, so that's about all I have for questions. I'm not seeing anything else really come in. Oh, here's one. Can spontaneous combustion occur in heating canola when a fan is turned on? What does the canola temperature need to be?
Yes, over the years, unfortunately, we've seen fires in bins with canola, with sunflower in particular. That if there's heating that is occurring because of the wet conditions, under certain scenarios, that can generate enough heat that it'll eventually switch into a chemical reaction and will elevate to the point of spontaneous combustion. It's not a common occurrence, but certainly it can occur. And so it's imperative, as was mentioned earlier, that we be monitoring the temperature profiles in these bins. And the first thing should be, anytime the temperature starts warming up, is to run the aeration fans to cool it mass down again.
I have one final one here. It might be a little bit hard to explain. So combined wheat at 19% moisture during nighttime operation of -5 to -10 degrees Celsius. The grain went into storage frozen, in quotation marks. So should the grain be rotated or left alone? If it's being rotated, should it be done on a cold day?
If it's cold going in, I'd say it should be, and the ambient conditions stay cold. I would probably leave it alone. Run some air through it to make sure that the conditions are even throughout the whole thing. But at that point, unless you want to take it out and dry it, just leave it alone.
Yeah, and I'd just add to that once we get moisture contents up above, about 15%, I've heard of a number of cases where the respiration heat does start warming the grain. So even though it went in cold, continue to monitor it so that if we do notice that temperature increasing, that we can aerate it right away to cool it down again.
Okay, great, thank you. I think that's about it. We've gone over by about 17 minutes here, so I'll wrap it up. We still have quite a few people that hung on, so I thank you for hanging on to our every words here. Thank you again to everybody for attending today's webinar. A huge thank you to Dr. Hellevang for bringing your knowledge on drying and also for lending us your time on the American Black Friday. I think we may have lost some attendees maybe to online shopping today, so we appreciate you giving us your time when you could have been with your family instead. So thank you very much for that, Dr. Hellevang.
You're very welcome.
Charley Sprenger, thank you weren't one of them Black Friday shopping, so we got you. Charley, thank you for your time and your knowledge today. Charley and Lauren are our local experts in Manitoba with PAMI. They'll also be at several conferences over this winter, embellishing on the information that Charley gave today. So I encourage you guys to sort of track them down and see where they'll be presenting over this winter, because there'll be lots of important information, I think, for producers out there this winter. As I mentioned before, check all of our websites next week for the recordings. For the handouts, you can go to the Corn Growers website, Manitoba Canola Growers, National Sunflower Association, Manitoba Wheat and Barley's websites, and possibly even the Canola Council of Canada's websites for these recordings, and also the handouts, since I know some of you were having issues with it. Any other questions? I encourage you to get a hold of Dr. Hellevang or Charley via email in the future for questions. So thank you everybody again so much. Hope you have a great weekend and take care. Thank you.